We want to begin learning how to factor trinomials. Trinomials specifically to have a leading coefficient of a 1. So how we do that, we have to go back and remember how we multiplied binomials. And the way that a lot of us learned how to do that was this FOIL method. It was kind of double distribution, or the first term times the first produced the first term, last times last produced the last term, and then the outers and inner combined produce this middle term. And that's what I want to focus on right now. So remember, if we took the inner terms, then added them to the outer terms, that would produce that middle term right there. So we can kind of wrap our head around that and kind of remember that that's comfortable. We've practiced that. We've learned how to do that. Then we're going to be able to take a trinomial and work our way backwards. Remember, that's what factoring is. Multiplication goes one direction. Factoring just pulls them apart back the other direction. So let's look at an example here. X squared plus 6x plus 8. We want to factor that trinomial, and notice the leading coefficient is a 1. So that's important because that allows us to begin with just a parentheses where we know the first times the first, which produces that x squared. They both have to be x's. There's nothing else they can be because it's only x times x that makes an 8 squared. However, there's lots of ways we can make an 8, that last term. Remember, last times last produces that last term. So here's one example, x plus 1 and x plus an 8. 1 times 8 makes an 8. How about x plus 2 times x plus 4? 2 times 4 produces an 8. I can think of two more, at least. We can also do an x minus a 1 and an x minus an 8. Negative 1 times negative 8 produces a positive 8. And then I can also do an x minus a 2 times x minus a 4. All of these binomials here, when I multiply, first term times first term produces an x squared. And all of these, when I multiply the last times the last term, produces the 8. So what we're interested in is, remember, is that middle term. And how do we get the middle term? That's when we added the outers and inners, which basically means if I look at all these numbers, 1 and 8, if I add the 1 and the 8 together, does that produce a 6? No. Does any of these, if I add the last number or add the inners together, a 1 plus, or yeah, I kind of lost it there, 1x plus there, those coefficients, looks like it's only right there where the middle terms, 2x plus 4x, add together to make a 6x. So that's how we hunt for factoring trinomials. We kind of narrow the list down a little bit, figure out what are all the ones that make the first terms happen, what are all the ones that make the last term happen, and then we go in for the kill. What are the ones that make the inner term happen? And in this case, out of my 4 possibilities, it's only x plus 2 times x plus 4 are the factors of x squared plus 6x plus 8. Now in this one, I want to use a technique which is real similar to what we've already showed you, but here's how I kind of think about doing these problems, and you can see if it works for you. First of all, we have a trinomial, leading coefficients of 1. It's not there, so it's understood 1, which means that let's see if it factors directly where the first terms are x's. Now I know that these last terms have to do two things. One, they have to multiply to become a 6. So let's just list off all those possibilities. A 1 times a 6, a 2 times a 3, a negative 1 times a negative 6, and a negative 2 times a negative 3. Those are all my factors of 6, or factors whose product becomes a 6. So I was able to narrow it down to 4 opportunities. From there, I want to find the pair that if I were to add them this time, produces a negative 5. So multiply to make a 6, but I'm looking for the only pair that if I were to add them, make a negative 5. Do you see them? Looks like this last pair right here meet those two conditions. Multiplying makes a 6, adding makes a -5. So that means that my two terms here have to include a -2 and a -3. And let's find that out. Let's see if that's true. Let's multiply now and see if we get back to the original trinomial. First times first, x squared. Outer terms produces a -3x. Inner terms, a -2x. Last times last produces a +6. Collect the like terms, x squared minus 5x plus 6. And there's my check. X squared plus 2x minus 35. Let's begin our factoring process like we've done before. Two parentheses. First terms are x's. Now from here, we want to find out all the products that make 30, or all the factors that make a -35. And I'm going to list them off. So one could be -1 and a +35. The other one could be a 1 and a -35. All right, what else can you figure out? 5s and 7s. So one could be a -5 and a +7. The other one could be a +5 and a -7. Any other factors when multiplied make a 35 or a -35? I can't think of any. And so from there, I want to find out, well, which one of these four pairs, if I were to add them together, make a +2. And it looks like it's these right there that do. So those are my ending terms. -5 and 1's a 7. And now I completely factored this original trinomial. We can also factor trinomials that are in variable of y. It doesn't always have to be an x, but the same process is the same. Of course the same process is the same, duh. So let's go ahead and put a parentheses in. First times first has to make a y squared. The only way to do that is a y times a y. Now we look for all the factors when multiplied to make a -99. So we have 1s and 99s. We have 33 and 3s. We have 11 and 9s. And you can see that the more factors this last term has, the more places we have to look. But fortunately, it's still a narrowed list. So do any of these, if I were to add them up, produce a -2? Looks like this one right there. -11 plus a 9 produces a -2. So those are what I'm looking for. A +9 and a -11. And so y plus 9 times y minus 11 produces y squared minus 2y minus 99. Why don't you be one step ahead of me here? What were you doing first? Okay, thank you. All right, now what do we do? Find all the factors when multiplied make a -5. So that's 1 and a -5, and looks like a -1 and a +5. I can't think of any others. So now we need to figure out which one of those two, when added, produce the coefficient in the middle, which is a 1. Oh, neither of them do they? Did we do something wrong? Or does this trinomial not factor? Maybe it's prime. Yeah, we can have trinomials that are prime, which means they don't factor. So we would say that is already in its factored form. It's already reduced. I can't do anything with it. Just like if I had like a number 13. 13 is a prime number. I can't find two factors that multiply to make a 13. Likewise, I can't find two factors when multiplied produce an x squared plus an x minus 5. So it's fine. We can simply say it's prime. Now this one has a little bit of a twist to it. Notice that there's two variables in it, but it's still a trinomial whose leading coefficient is a 1. So it's not too different. So let's begin how we've begun before. Create two brackets or two parentheses. First times first has to be x's. Now the last one, notice the last term has a y squared in it. So last times last, there has to be a y in the last terms. However, we don't know what the coefficients are. So let's just think through now as if the y's were not there. What are all the factors that make a 6? 1 and a 6, a -1 and a -6, 2 and a 3, and a -2 and a -3. So out of those 4 pair, which ones add up to a -5? Looks like that pair right there does. So I would have a -2 right there, so a -2y and a -3y. And if you're not convinced, let's multiply those. First times first is an x squared. Outer terms is a -3xy. Inner terms are a -2xy. And the last terms are a positive 6y squared. Collect like terms, which are always the middle terms in this case. So x squared minus a 5xy plus a 6y squared. And that's our check. So when there's a y squared in that back term, don't let that scare you. We just know that we'll put a y in that second slot in both of those binomials. And then from there, everything's the same. Now we've been working on processes of how to factor a trinomial whose leading coefficient is a 1. Notice this one is not a 1. It is a 3. Whoops, I think that's a cube right there. So what do we do? Well, first of all, let's just see if something factors out of each of these terms. And I notice that a 3x is common to each of those terms. So let's factor that out first, and then let's see what happens. So I'll factor a 3x, and then from there, we parentheses everything else that's left. So I would have an x squared minus a 5x minus a 14. Okay, so I have 3x times x squared minus 5x minus 14. Pretty good. Are we done? Let's see if there's anything else that factors. Remember, we keep factoring till we can't factor anymore. Looks like I have a trinomial in here now that I might be able to factor. So let's keep that 3x. Factoring a trinomial means I put 2 parentheses with x's in the first slots of both of those. Now I'm going to find out all the factors that make a -14. 14 and -1, -14 and a +1, a 7 and a 2. Looks like those are the 4 possibilities. Out of those 4, which ones add to a -5? So I'd have a -7 and a +2. And now I was able to factor it completely. This one required factoring twice. One, I was able to pull something out of each of the terms. And then from there, the trinomial left, I was able to factor that. And another example how we need to factor out something first in order to completely factor it. So notice that I don't have a leading coefficient of a 1, rather I have a -16. And it's negative, because remember, we like to have what's left in the parentheses later as positive. So let's factor out a -16 first. And there's no t, so it's just a -16. What's left is a t squared plus a t, and 16 times 4, 5, 6. Looks like it's a 6. Whoops. And that's going to be, I'm factoring out a -16, so I have a negative t left. And over here I have a -6 left. And I just want to double check that if I multiplied it back, -16 times a t squared, -16 times a -t gives me a positive 16t, and a -16 times a -6 gives me a positive 96. All right, now from there, now we have a trinomial left, and notice we wanted to have this leading term in the parenthesis positive. And now you're starting to see why. Now we can factor this trinomial, or to see at least if we can. We're using variables t this time because this equation came from an object in motion due to gravity. And so there's an acceleration factor there. Bonus, don't worry about that right now. So factors of -6. That's a -3 and a +2. A 3 and a -2. 1 and a -6 and a -1 and a 6. And of all of those that add up to a -1, is only that one. So those are the remaining parts of my factors. So that factors completely to 16 times t minus 3 times t plus 2.